This is a pre-lab lecture on the empirical formula of a compound. In this lab, we will use magnesium and hydrochloric acid to make a compound. That's magnesium chloride. We will then determine the empirical formula of this compound. Hydrochloric acid is an aqueous solution of HCl. It's highly corrosive. Be sure to wear goggles, lab coat, and gloves. If HCl is spilled on your skin, rinse for 15 minutes. If it's spilled on your gloves, wash it off immediately. When magnesium reacts with HCl, both magnesium chloride and the hydrogen gas will be produced. Hydrogen is inflammable, so do this reaction in a fume hood. You may watch this YouTube video to see the production of the hydrogen gas from the reaction between magnesium and hydrogen chloride. Again, do all reactions in a fume hood for safety. Now let's look at the procedures. If you need to run 2 trials, do them simultaneously to save time. Label 2 evaporating dishes with a pencil, 1 and 2. Weigh both. Use a spatula to transfer roughly 0.2 grams of magnesium to each of the 2 dishes. Weigh both dishes again. Take the difference to obtain the mass of magnesium accurately. 0.2 grams is a very small amount. 4 drops of water is roughly 0.2 grams. When you get HCl solution, be sure to avoid cross-contamination. So never insert your own medicine dropper into the source bottle. Instead, if you are doing 1 trial, pour about 10 to 15 milliliters of this 3 molar HCl solution into a clean beaker. If you're running 2 trials, get roughly 20 to 25 milliliters. You do not have to measure the volume of the HCl solutions accurately. Just estimate. After you get both HCl solution and magnesium, take them to a fume hood. Add HCl to magnesium slowly. How slow? 1 drop every 2 seconds. This is because this reaction releases a lot of heat, enough to boil water. So again, add HCl to magnesium slowly, roughly 1 drop every 2 seconds, to avoid vigorous boiling of water. You may not need to add the whole 10 milliliters of HCl. Just add enough to dissolve magnesium completely. So it can be 8 or 9 or 10 milliliters. After magnesium is fully dissolved, you have an aqueous solution of magnesium chloride and a little bit unreacted HCl. So we will have to evaporate water and HCl to get 100% pure magnesium chloride. We'll use a hot plate for this purpose. When you evaporate water and HCl, the setting of the hot plate should not exceed 5. Again, this is to avoid a vigorous boiling of water for safety reasons. So be patient. But if you do observe the solution starts to boil vigorously. Use a pair of tongs or hot hands to remove the evaporating dish from the hot plate. Lower the setting to 4, wait a minute, and then place the dish back on the hot plate. This process may take about 40 to 45 minutes. When waiting for the product to be completely dry, use the time to record the experimental procedures, observations, raw data, and if you want to, you can do a little calculations. For example, the mass of the dish plus magnesium minus the mass of the empty dish is the mass of magnesium. If you run multiple trials, there's no need to repeat writing the same procedures or observations. Just record the raw data and perform the calculations. After 40 to 45 minutes, the product will look dry. It may be white or a little yellowish because of some impurities. That's fine. Keep the dish on the hot plate for 5 more minutes. At this point, you may set this hot plate to 6 or even 7. This is to ensure all water is evaporated. And then you can move the dish away from the hot plate, rest it on your bench, wait 3 to 5 minutes to cool it down before you weigh this evaporating dish again, now with magnesium chloride inside. Now you can calculate the mass of the product. It's very simple. Again, it's the mass of the dish plus the product minus the mass of the empty dish. So this is why you need to label both dishes at the beginning of the lab period. The mass of the product should be between 0.6 and 1 gram. If your number is much larger than 1 gram or much smaller than 0.6, there is something wrong with your calculations. What about the mass of the chlorine? Because the product is magnesium chloride, there are only 2 elements, magnesium and chlorine. Therefore, the mass of chlorine in the product is simply the mass of the product minus the mass of magnesium. Later, you can determine the numbers of moles for both elements, magnesium and chlorine, in magnesium chloride. And then you can determine the ratio between the number of moles of these 2 elements. That will give you the empirical formula of magnesium chloride. After you're done with the experiments, dissolve the product with hot water and pour the solution into a waste bottle. Finally, clean up and ask your TA to check and sign your notebook.